Peace, peace. Welcome to Finding Equivalent Fractions. Equivalent fractions are, or rather, an equivalent fraction is a fraction that is equal to another fraction. I definitely want to start by saying that first. So, before you can find an equivalent fraction, you need to start with any old regular fraction. So, for example, you start with something like 1 over 2, right? 1 over 2. And equivalent fraction, an equivalent fraction for, look at that, man. An equivalent fraction for 1 over 2, it's actually right, is 4 over 8. Equivalent fractions are fractions that take up the same amount of space, but they look different, right? So they take up the same amount of space, but they just look different. Well, to be more specific, they use different digits. They use different numbers, but they take up the same amount of space. So let's go through some examples on a couple of fractions and how to find equivalent fractions for them. So let's start with something like 1/3. If we have 1/3 as our starting fraction, again, if you're gonna find something equivalent, you gotta have you can't find an equivalent fraction if you don't have a fraction to begin with, if that makes sense. What is the equivalent fraction equivalent to? You know what I'm saying? So we have to start off with, we have to have a fraction that we start off with to begin with, right? So if you want to find something equivalent to 1/3, right, which is going to be what we start with, all that we have to do is multiply the numerator and the denominator by the same number. That's all we got to do. So 2 times 1, it's going to be 2. And 3 times 2, it's going to be 6. So 1 over 3 and 2 over 6 are equivalent fractions. They take up the same amount of space, but they use different numbers. Let's get into another example. We'll do a few of these. Let's say you have a fraction like 4 over 7. What is a fraction that is equivalent to 4 over 7? And just to, I'm going to change up the language just a little bit. Instead of saying equivalent, we need to find another fraction that take up the same amount of space but use different numbers. And so again, we're going to do the same thing that we did in the previous example. All that we have to do is multiply the numerator and the denominator by the same number. So let's do 3 this time. You'll multiply both of these by 3. 4 times 3 is 12, and 7 times 3 is 21. So 4 over 7 and 12 over 21 are equivalent fractions. What does that mean? That means that they take up the same amount of space, but they use different numbers. That's all that please don't let nobody else tell you different. Because they just trying to make it more complex than what it is. Let's go on to another example right fast. A couple more examples. Let's say we have a 2/5. Right? Let's say we got 2/5. Again, we need to, we're asked to find an equivalent fraction. So let's find, as a matter of fact, so let's find two equivalent fractions instead of one, right? So let's do this. We'll multiply the numerator and the denominator by 2. And so we'll get 4 over 10 as an equivalent fraction, right? And then let's also take 2 over 5 and multiply the numerator and denominator by 3. 2 times 3 is 6, and 5 times 3 is 15. So 2/5 and 6/15 are also equivalent fractions. And so is 4 over 10. So 2/5 is equal to 4/10. 4/10 is equivalent to 6 over 15. So again, all of these fractions, 6 over 15, 4 over 10, 2 over 5, they take up the same amount of space, but they use different numbers. Let's go for about 2 more examples. Let's say we have a fraction 5 over 6. And let's multiply this one by 1. 5 times 1 is 5. 6 times 1 is 6. So this, if you ask me, would not qualify as an equivalent fraction. These are just the same fraction. This is just the same thing. It's not equivalent because they use the same numbers. 5 over is really too plain to discuss. 5 over 6, of course, is equal to 5 over 6. So let's try using let's scale this fraction by a different factor. Let's scale it by a factor of 2 instead. But remember, it has to be the same number. So it has to be, the numerator and denominator multiplied by the same value. They have to be scaled by the same amount. So 5 times 2 will be 10. And 6 times 2 will be 12. And so 5 over 6 and 10 over 12 are equivalent fractions, because not only do they take up the same amount of space, but they use different numbers. If it's the same number, then we really don't even have to look at it. And let's end with one more example. Let's do 3 over 8. 3 over 8. So let's find a fraction that is equivalent to 3 over 8. Let's scale this one by a factor of 4. Multiply the numerator and denominator of this fraction by 4. 3 times 4 is 12. And 18 times 4 is 32, if I'm not mistaken. And so 3 over 8 and 12 over 32 are equivalent fractions. And what does that mean? Just for the one time. Equivalent fractions, 3 over 8 and 12 over 32, they take up the same amount of space, but they use different numbers.